Welcome back. Now that we have been introduced to the concept of electric circuits, let's dive into some of the principles that govern how they operate. Their operation is governed by what is called Ohm's law. Ohm's law states that the electric current I in a given metallic conductor is directly proportional to the potential difference V between its ends, provided that the temperature and dimensions of the conductor remain constant. Mathematically, we can simply write the current I is proportional to the potential difference V. To remove this proportionality sign, we have to introduce a constant. Now, if we make K the subject of the formula, we now have K equal to V over I. This constant is a measure of how much the conductor opposes the flow of current, and it is known as resistance, represented as R. Therefore, our constant K now becomes R. This is the formula for resistance, and this formula also represents Ohm's law. How about we use an analogy to help us remember this relationship? Let us picture an overhead tank filled with water with a pipe leading to a tap on the ground. The potential difference V is the difference between potential energy of 2 points on an electric field, right? In this case, the tank is our source, and the potential difference will be the difference in height from the tank to the tap on the ground. Now, since current I is the speed or rate of flow of charges in a conductor, this is represented by the speed of the water coming out of the tap. So now we know the higher the height, the faster the water will be coming out of the tap. And in this case, our conductor is our pipe, and the water are the electric charges, and the height of the pipe is the potential difference. Now suppose for the same height of the tank, we put in 2 pipes, with the first pipe being labeled A, having a large diameter, while the second pipe labeled B has a smaller diameter. I guess you know that water will flow a lot faster from pipe A because it offers less resistance to the flow, while in pipe B, the water will flow a lot slower than pipe A because it offers more resistance to the flow of water. Now note that some materials do not follow Ohm's law. Such materials are called non-ohmic conductors. Some of these materials include semiconductors like silicon and components such as triodes, rectifiers, and thermostats. These are useful in circuits, especially when we want to keep a steady voltage even when there is a change in current. Now, conductors that do follow Ohm's law are called ohmic conductors. And that, my friends, is Ohm's law in a nutshell. It says that the current in a conductor is directly proportional to the potential difference between its ends. This means that as voltage increases, the current also increases. And we also learn that for a given voltage, the greater the resistance, the less the current in the conductor. See you all in the next lesson. Bye for now.